Research geophysics. That sounds like something that has to do with geology and physics. Maybe the movement of Earth. Otherwise known as seismology. This girl's walking the animal science room. Good Lord. Have you been here before? Please tell me you have.
I don't know why I offered to do this.
Please tell me you've been here before.
Yes, I am. Hey! Good, how are you? Breadcrumbs, please. Brent, this is Rob and this is Chris.
Hey, Robert.
Pleasure to meet you.
How you doing?
Good, thanks. It's a hard one. I think that the question was, what kind of earthquake would have happened during so and so event?
He wasn't wise like I would have been.
Yeah, we just had. Looks like a nice little Canadian earthquake right here. And it was just a rock fall in Mount St. Helens. I'll look around and maybe a little
A
earthquake.
rock fall?
Yeah.
What about Mount Baker? It was all steaming up yesterday, and then they said it's normal.
Yeah, Mount Baker, tends to do that. Mount Baker has a lot of active thermal vents on top, and when the weather conditions are right, you can see them.
That's why they said they could see it yesterday.
Yeah. Here indicates a station that we have in the field. We have now, I don't know the exact number, but probably about 130 to 140 stations out in the field. Each symbol here represents a different kind of station. As you look on this map, the most the most frequent symbol you see is the red triangle, and the red triangle is what we call a short period seismograph station. And what a short period seismograph station is it's a station that is really sensitive to detecting earthquakes. This instrument can record the amount of energy release. If I had a rock in my hand and I placed it on the lab bench, and I took a hammer and I broke that hammer, the amount of energy released in that rock breaking could be detected from this instrument about 13 kilometers away.
No.
This instrument is extremely sensitive. A high-tech instrument. This has been around for quite some time, probably for 30 years now, 40 years. And the technology behind it is pretty simple. Do you guys know what happens when you have coiled copper wire and you take a magnet and you move a magnet over coiled copper wire?
Like a generator.
Right, it creates an electrical impulse. You have the magnetic field of basically the same thing. This is a magnet. And if you don't believe that this is a magnet, so you have a magnet, and then you got coiled copper wire. So what we want to do is, see if I can do this correctly.
Fisheye lens.
No. Hey.
Hey.
Hey. Amy, this is Chris. Chris is the thing.
So what happens is you have this magnet suspended over a copper wire. So what happens is when the ground shakes, this magnet remains stationary in relation to the copper wire. So then this is what happens.
Oh, slick. Let me get an overview. So that stays straight.
And this moves back and forth. That's right.
And that's how you get the...
Yeah. So now.
And that's what on this right here, that one? Oh, all right.
See, so that brings up another point. So we've got 130 instruments out in the field, and we have to know when this is happening. We can't have someone standing over every instrument. So what we have to do is we have to find some way to get this signal back to our lab. And if we flip back to this map, this shows what we call our telemetry, how we get this stuff back to our lab. And every one of these lines, on the purple kind of lines, indicate an FM receiver.
That's what I was going to say, radio, right?
Radio, that's right. So they've each got their own megahertz that they transmit at, and we sometimes use microwave or dedicated phone line. So BPA has provided microwave connection. So what happens is a lot of times they come into a hub and then sent via phone line or microwave up to a tower in Queen Anne. And then from Queen Anne we directly own telephone lines right back into our computers.
That's why.
So we're basically getting real-time information on all our stations all the time. Really.
So everything goes in that machine and everything's recorded, or you can tell every single one of
Yeah,
them
you
by
can tell
this.
whether they're around, whether they're alive, like these guys. And you can tell whether they're alive because we can actually monitor the waves as they come in. I don't know how to use this machine. They don't let me use
Oh, I
it.
used to use one of these.
Did you?
Yeah, I was the oscilloscope, right?
Oscilloscope, that's
Yeah,
right.
and it brings the wave. Yeah, you gotta know all that
Yeah.
craziness.
I don't know how to use that. I've watched it. They've tried to. They gave me a 1 minute lesson.
Yeah. I used to try to fix them if they were broken, but not anymore. Man, that's wild.
So what happens is this baby's got 132.
Is that in Israel?
You were what? Sleeping your life.
I was sleeping.
Okay, Tracy thinks this isn't the way we came.